Hello everyone, welcome to the last experiment of our online session. So for today's experiment, you were supposed to design your own circuit and implement it. However, for different mode of operation, we have designed the circuits and have implemented them. Through this experiment, you will learn how to design an experiment to accomplish specific objective. So through the experiment, you will collect, analyze, and interpret the data and use your own engineering judgment to draw conclusions. This experiment has two parts. So in first part, you were asked to determine the value of an unknown capacitor. To do that, we have a simple RC circuit where you can see we are going to use the value of the resistance as 1 kilo ohms, and the input voltage will be 2 volt peak to peak, and the frequency is going to be 200 hertz. As we know, the time constant tau is equal to RC, so we know the value of R from this circuit, and we're going to figure out the value or find out the value of our time constant through the experiment. And from there, for using this equation, tau equals to RC, we're going to calculate the value of the capacitor. In the second part, you are asked to design an experiment where you can explain the operation of a function generator setting output impedance. What you have to do is over here, we're going to change the impedance both for the function generator and the load impedance, meaning that we're going to start with 50 ohms load resistance, where we'll keep changing the impedance of the function generator from 50 ohms, 100 ohms, 500 ohms, 1 kilo ohms, and high Z. Then we'll move to 1 kilo ohms load resistance, and we're gonna change the impedance of the function generator from 50 ohms to high Z. And we will do the same for 5 kilo ohms load resistance. And in here as well, we're going to use 2 volt peak to peak input voltage amplitude, and the frequency going to be 200 hertz. So please have your notebook ready with you, and we also encourage to see the entire video. Please pause the video as you will have to take down data and interpret the data accordingly. So please be careful while taking the data. And as you know, this experiment or this lab report is due from 1 week, and it is a group lab report, and the group is posted on Canvas. So for the first part, we're going to implement this schematic, a simple RC circuit, where we're going to use 1 kilo ohms resistor and 2 volt peak to peak voltage with frequency of 200 hertz. This is the first part of our last experiment. Let's look at the schematic first. To determine the value of an unknown capacitor, the schematic of the circuit is this one. As you can see, this is a simple RC circuit. The resistance is in series with the capacitance, and we're gonna give the input voltage across this terminal. So, and then we're gonna measure the output across the capacitance. Now let's look at the real circuit. We can see this is our resistance, which is 1 kilo ohms, which is in series with the capacitance. We're going to find out the value or capacitance of this capacitor. And now let's look at the input voltage. We can see, looking at the function generator, it's a 200 hertz frequency, amplitude of 2 volt peak to peak, and it's a square wave input voltage. As you can see that the square button is on, and when it comes to the circuit, we can see one probe is connected to one side of the resistance, and another probe, or the ground probe, is connected to another side of the capacitance. And I already compensated the oscilloscope. The probe of the oscilloscope is connected to the capacitor. One side is over here, you can see, and the ground probe is connected to the other side of the capacitance. Now let's look at the oscilloscope side. So over here, we can see this is the charging and discharging phase of the capacitor. It stays for a while and then it gets down. So this is the charging and discharging of the capacitor. We know that 63.3% is the maximum output voltage we can get, which is almost equal to the input voltage. So we're gonna try to figure that thing out. We can see this is our charging phase again, and then what we're going to do is that we're going to use the cursor to measure the x values or del x value. So from the x or del x value, which is the time axis for this graph, it also gives us the time constant, and we also know that time constant tau equals to RC. We know the value of R from our circuit, and we're gonna figure out the value for tau from this oscilloscope, and then we're gonna calculate the value of capacitance for the circuit. Now I have already selected the X2 from here. Then if I remove the cursor almost to the 63%, let's start doing it from the X1. So this is X1, sorry, this is absolutely in zero, it's starting charging. Then we're gonna go to X2. So if we think about this phase, the 100%, 63.3% is gonna be around this stage. So we're gonna put it around this stage. So now this is charging. It is not exactly, so this is 60, almost 63.3%. Now if we look at the value of del x, we can see it's 140 microsecond. So we have to calculate the value of C. As we know, tau equals to RC. We know the value of R is equal to 1 kilo ohm, and we know the value of tau from here, which is 140 microsecond. So we have to calculate the value of C from here. Then for second part, we're going to use first the load impedance as 50 ohms. Then we're going to change the impedance of the function generator from 50 ohms, 100 ohms, 500 ohms, 1 kilo ohms, and high Z. Then we will change the load impedance for 1 kilo ohms, and we're gonna keep changing the function generator impedance 50 ohms, 100 ohms, 500 ohms, 1 kilo ohms, and high Z. So this is the last part of our last experiment, or the second part. Let's look at the schematic first. So basically what we have to do for this experiment is that we have to match the impedance of the function generator and the load impedance or the load resistance. So we're going to change both the function generator impedance and the load impedance or resistance. Looking at the circuit, you can see it's a very simple circuit. The load impedance or resistance is in series with the impedance of the function generator. We're gonna measure the output across this resistor. Now let's look at the real circuit. Here is our resistance, which is 50 ohms in this case, and the function generator is connected. We can see the function generator is connected from here and to the resistance. One probe, or the positive side, is connected to this side of the resistance, and the ground is connected to this side of the resistance. And the oscilloscope is also connected across the resistance. One probe is here, another probe, the ground probe is here, you can see. So let's look at the function generator first. First, we're gonna we're going to choose a frequency of 200 hertz, and the amplitude is going to be 2 volt peak to peak. And then we're going to change the impedance of the function generator. First, we're going to start with the 50 ohms impedance. As we see that when we change the 50 ohms, when we put the 50 ohms, the amplitude of the function generator changes. So we have to put it back to 2 volt peak to peak. Here it's 2 volt peak to peak. Now let's look at the oscilloscope. We can see the peak to peak voltage at the oscilloscope is 2.07, almost 2 volt, and the frequency is 200 hertz as well. Now let's change the impedance of the function generator. Previously we used 50 ohms. Now we're going to use 100 ohms, and we can see that the amplitude changed, so we're going to have to put it back to 2 volt peak to peak. It's 2 volt peak to peak. Now we can see the impedance. As the impedance changed, the peak to peak voltage of the output voltage also changed. It is 1.55 volt now. Let's change the impedance of the function generator again. We use 100 ohms. Now we're going to use 500 ohms. So 500 ohms, let's go back. We see the amplitude change. We're going to have to go back to 2 volt peak to peak. This is 2 volt peak to peak. And what happens to the output voltage? Now we can see the output voltage is 1.15 volt. Again, we are going to change the impedance of the function generator. This time it's going to be 1 kilo ohms. Let's go back and see the amplitude change again. We're going to have to change the amplitude. This is going to be 2 volt peak to peak. Now let's see what happens to the output. The output voltage is 1.11 volt. Now for the last, we're going to use the impedance of the function generator as high Z, which we have been using for the whole semester. Again, the amplitude changed, so we're going to have to put the amplitude back to 2 volt peak to peak. Then the output voltage is 1.07 volt. So for the second part of this experiment, I have changed the load impedance of the circuit. Previously I used 50 ohms. Now I'm using 1 kilo ohms resistance as the load impedance. We're gonna repeat the same steps for the first one, meaning that for 50 ohms, as we measured, we changed the impedance of the function generator for 50 ohms, 100 ohms, 500 ohms, 1K, and high Z. We're going to do the same step for 1K load impedance. So here, when we look at the oscilloscope, I'm going to change the impedance of the function generator. This is so this is, you can see, this is for 50 ohms, load impedance of the function generator and 1K load impedance of the circuit. You can see the peak-to-peak voltage is 3.98 volt. Now we're going to change the load impedance of the function generator. This time we're going to use 100 ohms. For 100 ohms, it is 3.02 volt. Now we're going to change the impedance of the function generator to 500 ohms. That is 2.21 volt. Now we're going to change the impedance of the function generator to 1K. We can see the voltage, output voltage is 2.13 volt. Now we're going to use the impedance of function generator as high Z. The output voltage is 2.05 volt. The last part, we're going to use the load impedance as 5 kilo ohms, and we're going to keep changing the function generator impedance from 50 ohms, 100 ohms, 500 ohms, 1 kilo ohms, and high Z. And remember, in all the cases, we're going to keep the input voltage as 2 volt peak to peak, and frequency going to be 200 hertz. So now for the second part of the last experiment, I have changed the load impedance of the circuit to 5 kilo ohms. We're going to repeat the same steps for the previous two load impedances, like the previous two load impedances. So first we're going to look at the load impedance as 50 ohms. So let's put it 50 ohms. We're going to have to change the amplitude. This is 2 volt peak to peak. We see it's 4.14 volt. The load impedance of the circuit is 5K and the function generator impedance is 50 ohms. Now we're going to change the load impedance to 100 ohms. This is 3.14 volt. So the load impedance of the function generator is 100 ohms and the load impedance of the circuit is 5K. Again, we're going to change the impedance of the function generator. It's going to be this time 500 ohms. It is 2.29 volt. Again, we're going to change the impedance of the function generator, which is going to be 1K. So for 1K load impedance, it is 2.21 volt. Last, we're going to put the impedance of the function generator as high Z. The amplitude has to be 2 volt peak to peak. For all the measurements, it is 2.13 volt. So again, I'm repeating that this impedance is 5K, and we change the impedance of the function generator 50 ohms, 100 ohms, 500 ohms, 1K, and high Z. You have to explain when the load impedance of the circuit matches with the impedance of the function generator, what happens, and when it doesn't match, what happens to that circumstances as well, you have to explain. Remember, this is a group lab report. Do not submit individual report, please. Thank you. Developed an experimental procedure where we determined the value of an unknown capacitor, and also we developed a procedure where we explained the operation of the function generator with the output impedance, meaning that when we have changed the output impedance and the impedance of the function generator, how it is related to each other. When the impedance matches, what happens, and when it doesn't match, what happens as well. Remember, the report is due from 1 week now on. It's a group report. Don't submit individual report, please. If you have any questions or concern, please ask us questions. And thank you very much for watching the video. Good luck.